The first space shuttle to fly was dubbed Enterprise. This was only after the American public, and in particular the science fiction fan element, pressured NASA to name it after a popular TV franchise's spacecraft. Unfortunately, Enterprise was purely an atmospheric test vehicle and never destined for orbit. The Space Transport System, STS for short, or more commonly known as the Space Shuttle, was to be a great leap forward in space transportation. It was a reusable launch vehicle that could carry large payloads to orbit, then return to Earth as an unpowered glider, where it would be quickly turned around and readied for another flight. Reusability to reduce costs. The shuttle would become the most advanced and complex machine ever built. It would be a two-stage vehicle, the shuttle with three main engines fed from a large external tank, which had strapped to it two solid reusable rocket boosters.
This animation shows how they work during launch. The two solid rocket boosters strapped to each side carry their own propellants and burn for about 2 minutes before separating. Their onboard parachutes will then bring them back to Earth for recovery and reuse. The large external fuel tank continues feeding the shuttle engines for an additional 6 minutes, separating just before the shuttle reaches orbit. This is the only part of the shuttle system that will not be used again.
Once achieving a low Earth orbit, the cargo bay doors would swing open to access its cargo and dissipate unwanted heat from the launch. Unlike any of its predecessors, the shuttle dwarfs the conventional capsule and would provide room for a crew of up to 8 astronauts and specialists on 2 decks, with additional workspace available when flown with Spacelab in the cargo bay. The shuttle stack is a little under half the height of the venerable Saturn V moon rocket, but would utilize all the facilities, including the vertical assembly building and launch crawler. The first spaceflight-capable shuttle was Columbia, or OV-102. As large as a commercial aircraft, the Columbia was 37 meters long, with a wingspan of 24 meters, and its large vertical stabilizer making it 17 meters tall and weighing 75,000 kilograms when empty. The shuttle's payload bay, at 18 meters long, could carry up to 29,500 kilograms of payload. A vehicle of this type required new technologies and new materials to be developed. A case in point, the thermal tiles that cover the orbiter and protect it on re-entry into the Earth's atmosphere. This high-temperature, reusable surface insulation was made of 97% pure silica sand, and each tile was unique in size and shape, and all were attached by hand. These tiles could withstand temperatures up to 650 degrees Celsius. The nose cone and leading edges of the wings, where the highest temperatures on re-entry would be achieved, were made of reinforced carbon-carbon and could withstand 1650 degrees. The white upper sections of Columbia were designed to withstand 370 degrees. The main engines of the orbiter were also the pinnacle of rocket motor technology. Burning liquid hydrogen and liquid oxygen, it can produce a rated thrust of 1.7 million newtons, and thrust is variable from 65 to 109% of this rated value. The supercool hydrogen fuel is pumped around the engine nozzles to keep them cool before entering turbo pumps that are also driven by propellant pressure, making them very efficient engines. Each launch of the shuttle will only require 8 minutes of main engine burn. Designed to last for 7.5 hours, each engine should see out 55 missions. In that 8 minutes, the 3 engines will consume 540,000 litres of liquid oxygen and 1.5 million litres of liquid hydrogen, all fed from the 47-meter-long external tank. Originally painted white, NASA quickly realized a weight saving of 455 kilograms could be made if it wasn't painted, leaving the orange-brown urethane insulation exposed. The third and final component of the shuttle system is the 2 external solid rocket boosters. Each 45.5 meters tall and capable of 11.8 million newtons thrust, they were required to help lift the shuttle stack in the initial stages of launch. These were assembled from sections and fitted with parachutes so they could be recovered and refurbished. The largest solid fuel rocket ever flown, they burn for just 2 minutes and then are jettisoned from the main tank. With aerodynamic and landing tests complete, there was now only one test left to perform: a launch. Assembled and fueled, the shuttle Columbia sat on the floodlit pad April 12, 1981. This was the first time in NASA's history that they would perform a test launch of a new vehicle system with pilots on board. And they were pilot Robert Crippen and seasoned veteran astronaut John Young commanding. Young held several distinctions, including having walked on the moon, piloted 4 different types of space vehicle, and being the first man to make his 6th flight into space. Both astronauts were aware of the additional hazards of this flight. There was no traditional launch escape system as on previous manned flights. This first shuttle flight was fitted with ejection seats, their effectiveness at such speeds and altitude a gamble. Secured aboard their craft, ground computers armed with the most complex programming ever written began the final countdown. The 3 shuttle main engines ignited, the entire stack twanging back and forth, held down by explosive bolts. Then the solid boosters ignited, the spacecraft slowly rising from the launch pad. After being grounded for 6 years, America was returning to space.
Roger, roll. Program complete. Roger, roll complete.
The shuttle performed exactly as had been predicted by computer simulation and hoped for. Achieving low Earth orbit of 307 kilometers, the first priority was opening the cargo bay doors. Attached to them were radiators that would help cool the craft from the heat it had gained in the launch process. Young and Crippen then set about testing the complex systems and controls. In orbit, the shuttle can maneuver and deorbit with the use of the OMS engines, 2 smaller motors clustered with the main engines. It also has numbers of maneuvering thrusters. It was on these OMS pods that it was discovered several thermal tiles had come loose and been lost. As they were not critical thermal areas, it was deemed not a serious threat to the craft on re-entry. STS-1 remained in orbit for only 2 days and 6 hours, then began the critical test of re-entry and landing. Edwards Air Force Base, where previous landing tests had taken place, was the chosen site for the first operational landing.
3, touchdown. Houston, Columbia's on the roll. Welcome home, Columbia. Beautiful, beautiful.
After close inspection of the orbiter, it was found that many thermal tiles had either been damaged or lost completely. 2 tiles on the critical lower surface were damaged enough to allow hot gases to enter the vehicle's interior structure, causing severe buckling of one of the landing struts. Also noticed were the computer errors in predicting the control performance of the orbiter at high speeds in the atmosphere. These issues were quickly corrected for the next launch. The shuttle was returned to Cape Kennedy via 747, and the refurbishment begun. In November the same year, Columbia lifted off for the second time. The first time a spacecraft had been in orbit, then returned for a second time. Then again, and again. In all, there were 4 shakedown missions performed by Columbia, each launch proving the capability of this flying machine. One of the components tested during these flights was the Canadian-built Shuttle Remote Manipulator System, which lay along one side of the cargo bay. Also called the Canadarm, it is 15.2 meters long and 38 centimeters in diameter and weighs 410 kilograms. Divided into main sections, they are called the upper and lower arm. It has 6 joints, giving it the same flexibility as a human arm. It is connected to the shuttle by the shoulder connector, and the other end connected to the wrist is the end effector that can grab payloads by specially designed capture points.
Some general comments on the arm operation. The operation is smooth. There's definitely a little bit of flex and dynamics, but in the augmented modes, that's very minimized. Really no surprises. If there are any surprises, they're all pleasant. I'm really impressed with that piece of machinery.
The arm carries several cameras to enable the operator to see all the joints and their locations at all times. This also gave the astronauts the ability to inspect other parts of the orbiter not seen from a porthole. STS-5 carried 4 astronauts into space, where they performed the first 2 satellite deliveries. Bound for geosynchronous orbits, the shuttle deployed the communications satellite with a PAM booster, or Payload Assist Module, attached. They were spun up to a stable speed and spring-ejected from the payload bay. At a safe distance from the shuttle, the PAM rockets would fire, placing the satellite into the correct orbit. STS-5 was also the first flight of the shuttle where the crew did not wear pressure suits in the launch or landing phases. This procedure was the same for Soyuz until Soyuz 11, when 3 cosmonauts perished from a rapid pressure leak. By April 1983, it was the turn of the second orbiter in the fleet to be flown. Because the Challenger's airframe had been built as a test for shuttle construction and completed sometime before Columbia, it was identified as Orbiter OV-099. The frame manufacture was so good, NASA decided to save money and use it as the basis for the next orbiter. It had several modifications in design from Columbia, with fewer thermal tiles and more use of the Nomex felt insulation. It also introduced head-up displays in the landing phase, and the cargo bay was modified to carry a Centaur G upper stage for future missions. There were to be 4 spaceworthy shuttles in total. Discovery and Atlantis were still to be fitted out. 4 shuttles would be the ideal number to maintain a regular flight to low Earth orbit. Challenger and flight STS-6 would again carry a crew of 4 and the first of the TDRS satellites. These $100 million communications and tracking satellites would become the primary communications channel between NASA and space vehicles in orbit. The massive satellite was elevated up and eventually jettisoned from the cargo bay. Attached to the satellite was a PAM unit which would raise the satellite to a geosynchronous orbit. There it would be deployed, extending solar panels and large antennae. The system would require a total of 9 TDRS satellites, with 3 satellites as the main element. Each would have 2 replacements if required. The system will allow extended communications with orbiting spacecraft and an increase in data exchange. The ground elements of the tracking network included Goddard Space Flight Center, White Sands Complex in New Mexico, and a station in Guam. This network will also allow communications with ground bases in remote areas like Antarctica to be linked with a high-speed data and communications capability. Other orbiting facilities would go on to use this satellite network. Soon-to-be-launched Space Telescope Hubble would use it, as well as Landsat satellites. Primarily financed by the Pentagon, the TDRS system also carries extensive military and classified traffic. Challenger quickly became the workhorse of the shuttle fleet. For the next 2 years, Challenger would fly 85% of shuttle missions. STS-6 would also be host to the first tethered spacewalk for a shuttle mission. The two mission specialists, Don Peterson and Story Musgrove, donned the newly designed off-the-rack spacesuits and maneuvered themselves out through the cargo bay airlock. Remaining tethered to the spacecraft, the two men performed numerous tests encompassing the length of the cargo bay. The EVA of over 4 hours was the first for the Americans since Skylab. The newly designed EMU suits for the shuttle were the result of years of research into suit design. They consist of a rigid upper torso, which includes the arms, gloves, bubble helmet, and primary life support system, including electrical power. The lower, separate section is the lower torso assembly, a soft, flexible brief, legs, and boots. This includes the waist bearing, which seals the body. A liquid cooling and thermal ventilation garment is worn underneath, containing clear plastic tubing which circulates chilled water, and gas ventilation tubing. STS-7 was Challenger's second flight, and it carried a crew of 5, including the first American woman into space, Sally Ride, a mission specialist. The flight delivered 2 more satellites to orbit. They also deployed and then later recaptured the SPAS experiment package using the remote manipulator arm. The next flight was STS-8, and Challenger was the first night launch of the shuttle. It also took aloft the first African-American mission specialist, astronaut Guion Bluford. STS-8 deployed an Indian communications satellite and, in a money-making venture, carried 261,000 franked covers or stamps to be sold on the return for a profit. A scheme that, years earlier, had gotten 3 Apollo astronauts into hot water. Guess you can't keep a good idea down. The 11th shuttle mission, and Challenger's 5th, was the most daring yet. The major task was something never attempted before: the capture of a satellite in orbit, repairing it in the cargo bay, and setting it free again. The Solar Max satellite had been launched earlier in February 1980. It was to study the sun, in particular solar flares. A malfunction cut short its mission after only 11 months. They used the remote arm to snag the satellite and pull it into the cargo bay, where it sat on a special cradle. Then the astronauts went to work, replacing the faulty attitude control mechanism and the main electronics. One astronaut was strapped to the remote arm to better access parts of the satellite, although he didn't quite like it.
Really an uncomfortable feeling.
Do you feel like you're going to fall?
I feel like I'm going to fall.
Once repaired and checked out by ground control, the satellite was released back into orbit. Solar Max resumed its work studying the sun and went on working for another 5 years before plummeting back to Earth in December 1989. The mission was captured on an IMAX camera flown aboard the shuttle, and the film would eventually be released in 1985 as The Dream is Alive.
Procedures on the ground are being streamlined for the operational era. Processing time was cut in half during the orbital flight test program. Presently, it takes approximately 13 weeks to prepare the space transportation system for launch. It is projected that by the mid-'80s, there will be 2 shuttle launches per month.
And so the shuttle flights became more regular, achieving more each time with larger crews. The European Spacelab 1 flew, including experimental packages studying life sciences, plasma physics, astronomy, high-energy astrophysics, solar physics, atmospheric physics, and technology research. Numerous satellites were deployed, and scientific instrument packages placed in orbit, then retrieved by later shuttle missions. Discovery, the third shuttle orbiter, flew its first mission on 30th August 1984. She would go on to fly the most missions of all the shuttles and was the first to dock with the Soviet Mir space station. With each confidence-building flight, more were being planned, more goals achieved. Construction techniques studied in the vacuum of space for the upcoming International Space Station assembly. Atlantis, the fourth orbiter, was launched October 1985. The most advanced of all the shuttles, she incorporated all that had been learned from the earlier designs. By the 24th shuttle mission, over 118 astronauts and specialists had flown into space. Dozens of communications and specialist satellites had been launched. The first female spacewalk occurred during the 13th flight. Columbia had flown 7 missions, Challenger 9, Discovery 6, and Atlantis 2.
We have main engine start. 4, 3, 2, 1, and liftoff. Liftoff of the 25th Space Shuttle mission, and it has cleared the tower.
Within the blink of an eye, the 25th mission milestone had been reached. The STS had proven itself as an outstanding launch vehicle, capable of lifting satellites into orbit, retrieving errant ones, and repairing them in situ, saving millions of dollars. Carrying crews of up to 8 astronauts at a time and conducting extensive scientific research in orbit, the massive costs of development of the shuttle were paying off. With the proven flexibility to remain in orbit if weather conditions for landing were hazardous, or even selecting different landing locations, it was a shining beacon of American engineering and ingenuity.
Flight controllers here looking very carefully at the situation. Obviously a major malfunction.